How's it going, everyone? Mr. Geyser here with the final video in our lesson 13A series where in example 8 here, I'd love for all of you guys to go grab those TI-84 calculators in a small, short, but very important tutorial on how we find the intercept of two lines inside of our calculators. This will also allow us to try and solve out these problems here graphically instead of algebraically. For these problems here, like in example 8, we're given this exponent of 2 raised to the power of 3x is equal to 9. And we want to try and solve this graphically. The first thing we want to do is we want to try and open up our TI-84 calculators, and we want to try and plug in two equations. The first equation is that left-hand side. For us here, that y1 is just going to equal 2 raised to the power of 3x, and that y2 is just going to be a straight line at 9 there. To do that, we just go to our y equals part of our TI-84s. In that first option, I'm hitting 2, that hat, raised to the power of 3, and then I'm selecting alpha, and the stop problem here gives me that alpha x. So I have y equals 2 raised to the power of 3x. Now I'm going to tab downwards to get that y2 is equal to 9. I know I've done this right when I go over to graph here, and I happen to see both of my graphs intersecting somewhere in that top region. For me, luckily, I happen to see my graph inside of my view window. Sometimes that's not going to be the case, so let's actually manipulate our view window just a little bit, just so we have that practice here. To manipulate your view window, you're shifting the scale of that x and that y, or moving around that graph there to view a specific area. You're just selecting that window key right here. For me, I want to change that x minimum and that x maximum to -4 to 4. You don't always have to have it equal on both sides, but it is nice to have a nice equal left and right. So -4 for x minimum and +4 for x maximum. That y scale there just determines on how many tick marks are going to be on the actual axis itself. I'm going to keep it at 1, but I am going to change my y minimum and my y maximum to -4 and 15. Because I want to look a little bit higher above that x-axis to see where it intercepts. I'm just going to -4 here and down to 15. I'm going to keep my scale factor all the same. And when I go back to my graph, it's a little bit nicer to try and see exactly where that intersection is. Now, one way we can find an intersection is by looking at the table of points created by these two graphs. To do this, I'm actually going to hit second and go to table set. For this table set here, this gives me like a nifty way to actually set my table value to go to a specific x location. So as a side example real quick, if I wanted to know what value that y1 graph equaled at, let's say, 958. If I had my table start at 958, and then I hit second table, my first entry there goes directly to where that value is. It gives us an error in this case because our exponent would be like 2 raised to the power of like 20 or 2,100, which is like a trillion, billion, gazillion. It's a big number. But it goes to the specific x value that we then listed. We want to try and use that to narrow down where we're actually selecting in our table. So in our graph here, I know it's going to be right around where x equals 1. So when I go to second table set, my table start, I'm going to make it equal 1. Right around that 1 position is where our intersection is. And for my table delta, it's the change in x that creates those different rows. I'm going to make my delta there 0.01, where it's really, really small in between my x values. Now when I hit second table, I get all of these rows here with my x values increasing by 0.1 and my y values increasing in that second column. In this table here, I cannot change any of the values. If I go down to here and say 2.5, whatever, it doesn't allow me to change anything. These are just the calculated values of the graph that I've already put in. When I go down and scroll through these values here, I'm really just trying to find where my x value is, where it's equivalent to exactly 9. And unfortunately, I only get like a range. It's somewhere in between 1.05 and 1.06. This table trick works really well if I want to go to a specific x value, but it doesn't work well when I want to go to a specific y value. To do that, we need to use the intersect function on our calculators. Let's go back to our graph here. We want to try and find the specific intersection between those two graphs. To do that, hit second on your calculator, and then go to calculate above the trace on that fourth option. In calculate here, we're going to tab down or select the fifth option for intersect. Once we do that, it tells us to select the two different graphs that we want to see what's intersecting. So we could have like a bunch of graphs, like 6 or 7 graphs here, and select what 2 of them we want to intersect. We really only have 2 graphs that we can select. This Y1, where it's already selected for us in the beginning, so we'll hit enter, and that Y2, which it selected for us as a second. If we had multiple graphs, we need to tab up and down between those graphs there. We only have 2 here to select. When we select that second graph, it asks us for a guess as to right around where that intersection is. On that second graph, we're going to tab over to right around we think is going to be the intersection rays. We want to try and create some standard deviation of 1 around that intersection, meaning we want to be within -1 and +1 of the x of where that intersection is. So if the intersection is right around 1, we want to select that guess in between 0 and 2 of that x range. When we hit enter one final time, it gives us exactly that intersection of 1.566417. That is exactly what the calculator has calculated, not the hard exact answer, but we're just trying to solve this graphically. So we can only be as accurate as the decimal places that we're given. And in general with calculus, we want to try and be, or with pre-calculus, we want to try and use 6 decimal places in our answer here. So when we go back to our grid here, all we're saying is that the point of this intersection, what x equals, is that 1.056642. Thank you very much for joining me on these 3 videos in our Lesson 13A series here. If you have any questions, please let me know down in the comments, and I look forward to seeing all of you guys in class. Take care.